Now let us see velocity vector in this class. What is meant by velocity? Velocity is if a particle or an object moves from one distance to another distance in a particular time interval, then we say that it has velocity. Say for example, a car moves from one place to another, say the distance 100 kilometer. Let the car take 1 hour to cover the distance. We say that the velocity is 100 kilometer per hour. That is the distance divided by time. Distance covered by the car is 100 kilometer and the time it has taken to cover the distance is 1 hour. We say that the velocity is 100 kilometer per hour. We say it is speed, but when we say velocity, we also mention the direction. That is, the car moves in one direction, in one particular direction at a speed of 100 kilometer per hour. We say that it is velocity. The car has velocity. The velocity of the car is 100 kilometer per hour. Therefore, when we mention velocity, we mention the distance as well as time and also the direction. Therefore, the average, what is average velocity? Average velocity of an object is the ratio of the displacement and the corresponding time interval. The distance it has taken divided by the corresponding time interval is called the average velocity of an object. Now, you consider these four figures here. Consider this. O is the origin. This is x-axis and this is y-axis. Consider the object at point P. Let the object move. Let the object move in the direction, in the particular direction, given direction, from P to P1. We say that the direction of velocity vector is in this direction. Now let del R1 be the distance covered, that is the displacement. Del R1 be the displacement of the object. Del R1 is along the direction of motion of the object. Del R1. Let the object take del T1 to cover the distance. Therefore, here the object moves from P to P1. The displacement is P1 vector. Del R1 is the displacement. The time taken by the object is del T1. Let us see, del T1 is the time taken by the object in this. Therefore, the velocity is along this direction. The next figure, you see here, the object moves from P to P2. This is the direction of velocity. Del R2 is the del R2 vector is the displacement of the object. Let the object take del 2 time. Del 2 time. Maybe some seconds or hour, whatever it is. Del 2. Del 2 is the time taken for the object to move from P to P2. PP2 is the displacement. Del R2 is the distance vector, that is a displacement, and del T2 is the time taken. Now see the figure here. Let the object move from P to P3. Del R3 vector is the displacement. Let the object take del T3 time. And here, this is, the object is P and the velocity direction is in this direction. So in all this, what happens is that, what we observe here, as del T tends to 0, that is here del T1 is greater, that is the time taken by the object is here is greater. Again from here, from P to P2, it takes lesser time, del T2. Therefore del T1 is greater than del T2, that is del T2 is lesser than del T1. And here the object takes del T3. Del T3 is lesser time. right? So that is del T3 is lesser than del T2. That is, here it takes lesser time to cover. Here there is no displacement shown. Therefore, in all these three, as del T approaches 0, right? Del T approaches 0. That is the time taken by the object to move from one point to another point approaches 0. Del R vector approaches 0. That is, the displacement vector will also become 0. Therefore, this is the concept as del T tends to 0. That is, as the time taken decreases, keeps on decreasing, and when it becomes 0, del R vector, the displacement vector, it will also become 0. Right? Now let us see the further step. Now we can write velocity vector here. Velocity vector V we can write velocity vector is equal to limit del T tends to 0. Already I explained. Del R vector by del T. Therefore, this is the equation of calculus. We can write dr vector by dt. Velocity vector equal to dr vector by dt. So from here, I write del T tends to limit del T tends to 0. Already we have found out this del R vector del x I cap plus del y j cap divided by del T. Therefore, I write here velocity vector equal to separately limit del T tends to 0 del x I cap divided by del T plus limit del y tends to 0 limit del T tends to 0 del y j cap divided by del T. Therefore, V vector, velocity vector is equal to this value Vx, del x by del T is Vx, velocity along x direction, Vx I cap plus this value del y by del T is Vy j cap. Therefore, V vector equal to Vx I cap plus Vy j cap. This is the velocity vector along the direction of motion. And the modulus, the magnitude of the velocity vector, we can write velocity vector V is equal to, right, this is the magnitude, this is the vector component. Magnitude is square root of Vx square plus Vy square is the magnitude of the velocity vector. Right. So here, this is the velocity vector along x direction, velocity vector along y direction. Therefore, this is the angle, right, made by the velocity vector, resultant velocity vector, that is along the direction. The angle is theta with x-axis. Therefore, tan theta equal to Vy, opposite side divided by adjacent side. Tan theta equal to Vy by Vx. Therefore, theta equal to tan inverse of Vy by Vx. So, this is the velocity vector derivation.